Welcome back once again to AI Citizenship for Medicine. At this point in the module, we've provided a broad overview of artificial intelligence technologies, some of its promise and pitfalls within healthcare, as well as some deeper dives into large language models. Today we're going to round out this initial series of lectures with a discussion of some of the pitfalls and practical considerations when working with large language models specifically. As we've seen in previous lectures, large language models are flexible, powerful, and have been shown to be highly useful for a number of downstream tasks. Nevertheless, large language models do have a number of idiosyncrasies which are important to keep in mind as you work with them. In this lecture, we're going to be primarily focusing on the following three. First, we have the so-called hallucination problem. Large language models have become so consistent at producing coherent and grammatically sound text that it can often be surprising to find embedded within this text output text that is incorrect, nonsensical, or otherwise inconsistent with the user instructions. These sorts of erroneous outputs have come to be called hallucinations, both within academic writing as well as lay press. We will therefore use this term throughout this lecture, but do so with the caveat up front that we think that it's a problematic term. Using the term hallucination to describe this sort of output needlessly anthropomorphizes the model, arguably stigmatizes specific mental health conditions, and furthermore, even if we were to ignore these considerations and adopt a clinical terminology, a term such as confabulations would probably be more accurate. Nevertheless, to avoid confusion, we'll stick with hallucinations in our content for now. A second broad category of issues we'll discuss today involve reasoning ability and specific reasoning weak spots. Despite their ability to complete some remarkably sophisticated tasks, large language models have an inherently limited reasoning ability and may be liable to commit egregious logical errors even embedded within otherwise coherent text. Due to the way they are built and trained, most large language models also have a number of idiosyncratic weak spots, such as a proclivity to specific types of arithmetic errors. Lastly, given their ability to memorize and their easy accessibility via websites, which will often continue to train their language models on user data, large language models bring with them a number of security risks. As we've discussed, so-called LLM hallucinations are one of the major open problems in artificial intelligence research today, which is an extremely fast-moving field. In this slide, we present one published categorization of LLM hallucinations. The motivation for this slide is not for you to memorize this terminology, but rather to depict the various forms that hallucinations can take so that you can be on guard for them as users. With this in mind, in so-called fact-conflicting hallucinations, LLMs generate content which is frankly false, either because the content is imaginary, as when an LLM cites a paper which doesn't actually exist, or because it simply contradicts known facts and knowledge. In contrast, in input and context-conflicting hallucinations, LLMs generate content which may not be in isolation flagrantly false, but which contradicts either source context provided by the user or other output generated by the model itself. Related to the fact-conflicting hallucination problem, erroneous LLM output may also propagate human biases. In one recent analysis, LLMs were queried using 8 different clinical scenarios to assess for widespread misconceptions around race, and were found to propagate harmful, inaccurate, and race-based content. Of course, humans are not themselves immune to this phenomenon, and indeed, as the authors of this paper pointed out, surveys as recently as 2016 found medical students propagating similar content. So we clearly have a lot of work to do in uprooting this misinformation, both from our technologies as well as from ourselves. Now we're going to pivot a bit and discuss some of the challenges in LLM reasoning. As we've discussed through this chart in previous lectures, tasks involving complex reasoning tend to be some of the most challenging for current large language models. One particular pitfall for LLM reasoning that we wanted to call out in specific was situations in which LLMs are operating over content which shares a superficial similarity to common textual patterns found in the training dataset, but which nevertheless differs in key ways which can throw off the model. For a concrete example of what I mean by this, consider the examples shown on the right of the slide. In these images, LLMs are asked questions which are themselves completely straightforward, but which bear a superficial similarity to common riddles that the LLMs would have seen many times during training. Rather than simply answering the straightforward questions, the LLMs, at least in these samples, provided the answers to the riddle instead, even though this meant that the answer they were providing to the question was now incorrect. While the specifics of these examples may be rather silly, consider the analogous situation of a large language model deployed in a clinical context. Such a model may be used to review many clinical encounters that are very similar for the majority of their text, but which will differ in key pieces that could wildly shift the meaning of the content. If such a model were to exhibit the behavior we're seeing with these riddles here, the result could be a wild misinterpretation of the clinical information provided. Lastly, in this section on reasoning errors, we wanted to call out a few practical sticking points for most LLMs on the market today. Many of these may seem initially unintuitive, but start to make a lot more sense if you think about the LLM's underlying design and training process. For example, consider a large language model's relationship with numbers. LLMs have recently been shown to be able to construct complicated mathematical proofs, and yet often fail to perform basic counting. And one recent model could solve a problem from the International Math Olympiad, and yet falsely stated that the number 9.11 was greater than the number 9.9. This apparent contradiction in abilities makes a lot more sense when you consider that LLMs by default only understand specific numbers as vocabulary words that must be learned individually. While many more recent systems are now being augmented with the ability to invoke calculators and other tools to improve their mathematical reasoning, it is still worthwhile to have your proverbial antenna perked up for potential errors when LLMs are dealing with numbers. By the same token, idiosyncrasies of current model architectures will mean that many LLMs will struggle with things like new-to-model vocabulary words, tasks requiring temporal reasoning, and tasks that require either operating on longer inputs or generating longer outputs than the model was initially designed to handle. Finally, there are some issues in the behavior of current LLMs that may creep in as a result of the model alignment process. For example, some LLMs may exhibit what we could call people-pleasing or maybe reverse automation bias. By this we mean that most LLMs that you're working with have been aggressively tuned during alignment to be very agreeable to humans. As a result, they may sometimes backtrack too quickly and end up contradicting accurate assertions they had previously made when they received pushback from human users. Model developers appropriately attempting to mitigate systemic biases in their training data may also inadvertently introduce new biases or inaccuracies into their LLMs through overcorrection. For example, one recent multimodal model had undergone an optimization process to appropriately attempt to improve the diversity of the humans it depicted in its generated images. Unfortunately, this same optimization process ultimately led the model to depict Nazi-era German soldiers as people of color, eventually resulting in the shuttering of this model. This slide was already discussed in Module 1.3, so I'm not going to rehash the details, but I did want to place it here as a reminder, as there's reason to believe that these cognitive processes may be exacerbated in the era of LLMs, which are so much more human-like than previous AI systems. At this point, we simply don't have very much research describing the impact that interactions with LLMs will have on the human brain. Similarly to the last slide, it's extremely important to recall that your interactions with most commercial LLMs may be used in their own training corpora, and LLMs may repeat training data verbatim. On the topic of privacy, it's important to recall that in the United States and elsewhere, sensitive patient information has extremely strong legal protections, and that the type of information that's considered to be potentially identifying of a patient extends far beyond the obvious information such as a patient name or social security number. Furthermore, the process of de-identification, or the removal of sensitive information from the description of a clinical encounter, is an area that requires expertise and training. Finally, as of 2024, none of the major web-based commercial LLMs are HIPAA compliant. More secure versions of many of these models may be available through commercial services like Microsoft Azure, and yet other LLMs may be deployable locally on your own hardware. Nevertheless, it's safe to say that you should never conclude one of these tools is safe for handling clinical information without express review by one of the experts at your own institution. Our goal today has been to work through a few of the practical considerations in working with LLMs, with the goal of helping us all become as empowered as possible as the users of these systems. In the tables below, we've summarized a few of the key questions that you may consider bearing in mind as you interact with these systems, both entering inputs and interpreting outputs. And with that, we've reached the end of our first module in this AI Citizenship for Clinicians course. Future modules will cover advanced topics through lectures, Q&A sessions, and hands-on activities for more practice.